This is the nephew observability meetings for on February, I guess 5th for most people, 4th for Pacific, but 5th in 2024. Well, welcome. I would like that to be more or less like a let's see what we can do in L3 type conversations. But I think we have to level set on a lot of stuff before we get there. Well, before I get started, I guess if anyone has anything that they want to talk about before I kind of dominate the whole thing.
Maybe generally what you, in your perspective, would like to deliver for R3, and what is the scope generally for the nephew,
Yeah,
in
so
your
I'll
opinion?
try. Well, I'll try to present this, and then I think as a community we should get together and see what we're looking at for L3. Yeah, go ahead, Sebastian.
Yes, Stephen. Actually, I'm looking towards service assurance use case. So
Yeah,
where the
super.
observability plays very important role.
Mhm.
So two of the use cases we thought around them. It's just I feel if the observability in observability we can complete it. So one I would say collecting the any it's like a utilization related KPI parameter around the UPF, so that we
Mhm.
can focus on the scaling of the UPF. And the second around
Yeah,
yeah
that sounds. Yeah.
yeah
Mhm. Right.
second around the DU, which where the work group 2 actually they work. So they the DU actually they provide some KPI metric related to PRB. So those things we can collect and expose further. So yeah, these were the my two points that I wanted to discuss.
Oh, what group 2 has metrics already exposing? Is that what you're saying?
Yeah. So
Okay.
there's a OAI DU.
Oh,
So
okay.
yeah.
Okay.
So they are deploying
Okay.
it.
Oh, so UPF is one, and then you're saying that DU would be another one for OAI.
Yeah.
That's fine. We're building a framework, so we're supposed to integrate whatever actually works in
Yeah.
terms
So
of what's
yeah,
being
these 2
exposed.
points actually we can
Mhm.
add
Okay.
into this discussion. Yeah.
Okay. So cool. So
Yeah.
this is so let's get. So
Yeah.
I prepped some um, slides to just get the conversation going. So this is obviously not not decided this is the way to go or anything like this, but this is more just getting things kicking off. I think a few of us, not all of us, had attended the last 3 meetings. I think we had about 3 meetings, and they've been pretty sporadic. It's not very frequent, once every couple months, and it's preliminary discussions. And since then, Div left the project also, so we lost him. And then the last several ones, I think Vin was also here, and then there were some. I wouldn't say decision made, but there were some suggestions made. And then I think the kickoff we're talking about this. I'm not saying this is decided by the community, but there's a directions that we were going. Anyway, so very simple, right? I mean, what are we building really at the end of the day? We're building so Nephew at its core, at least up to release 2, is deploying network functions on a workload clusters. So through management clusters, going through a hydration pipeline, fully resolve resolve as much of the input parameters as possible. We establish a custom resource definitions for what most of the network function operators should be understanding what it is. And then the main job, we call it NF deployment. So the main job is to deploy network functions. And then we have workload clusters where you actually host the network functions, and then where the operator is running. So in that case, in terms of the observability path, is that the workload that is running right now, so many of these different workload clusters with some network functions running, should be able to send visibility data from their side. Well, A, expose it, and B, when they have this, they send it back to the management clusters, because obviously we're not asking users to individually log into to every single workload clusters, and then go check out what the status and what are the metrics and things are. And on that sense, even though most of our workload clusters are hosted by things that are not like really far edge things. We do have sufficient amount of storage and memories and CPUs mainly on a lot of the workload clusters. It's highly unlikely that we are hosting a full collectors at the workload clusters, because it's simply not very useful. Because again, we don't expect the human operators would be willing to log into a kube control into this, get the credentials of this particular cluster's kube control into this, and then access, like, let's say Prometheus, and then check out the time series data that way. So other than human, which human can also be accessing any of these collectors, there's also high-level applications that could be built. I put it in management cluster or outside management cluster. It could be some high-level applications that aren't really part of the management clusters, that are somewhere else, that was granted the right by the admins to be able to access the data. So the last time when we talked, we said that we are going to at least build a data lake to aggregate the data in all the raw data, unstructured data formats without any modifications into management clusters. And then, like any data lakes, you may be able to query it using SQLs and all the other things, or using APIs to tell, this is what we want to look at through a table. But usually, table format is probably the most common. And then you'll be able to grab it that way. And so this is pretty much, in a way, what we're trying to build, observability on a very high level. Go ahead, Pietro.
So I believe it depends on the scope, and we would like to target.
No, so this is very high level. That's why, like, just on high level, you have data, and someone will be able to access the data. Cool. So what does it mean when we want to get to that level?
I would like to commend the pushing all the data to the management, because I personally believe we need, at least in the broad scope, we need some data collection, and some mechanism to decide which metrics, logs or traces will be pushed to the management and which will be utilized locally, for example, by the operator or other components. And if you'd like to be scalable, in my opinion, you need to have such mechanisms that some data will be used for the closed loops on the workload clusters, but there will be decision that some will be pushed to the management, as just like you said, it may be used for those orchestration part, for the higher level application, or even for service assurance. And I do.
Yeah, but then
how do you see that?
At least you're not thinking there's a full-blown collector with storage sitting on the workload clusters, right? So we're basically not asking folks to say there are data that would contain within workload clusters, but we'll store them for like a very long time, and then anyone who wants, so machine can access it obviously, but then at the same time, if human wants to access it, they would also have to log into the workload clusters and read it. Is that one of the use case that you think that would happen? Or is it
operators, network function operators could use metrics, and those metrics
but then streaming in real time, streaming real time, react to them, sure, but then store them for a very long time, and then so that historically they would run like analytics or something on the workload clusters. I don't know if or not this is actually a very strong use case.
Do you expect operators to use those data? If so,
yes,
there will be really, it's not sufficient. You are pushing the data to the management, and then they are going to return to the workload cluster. And just like I said, it probably depends on the scale, on the
no. So operator able to access the data is a thing that I'll have on this deck later on. But then in terms of storing them for a long time, for whatever purposes, I like to see the use case to see whether or not we should have, like, allocated storage for historic sets of visibility data stored in the workload clusters. So that's, I'm not making that assumption, but obviously, again, this is a kickoff meeting. I'm open to use cases, and then as a community, we're building what we think is correct, right? So yeah, it would be good to know what the use case is in terms of storing it. But yeah, operator or some other controllers in the workload clusters able to access that data for sure. but then, you know, in terms of like storing them, which is what we expect here, right? We're storing time series, so we expected to store historic data perspective, and then I don't know whether or not this is something we want to do in workload clusters. We can examine that, obviously, if we have a good use case.
So to comment, for me, the use case is the use of data by the operator. I understand that they can use the data from the management based on the state of the art I was doing lately. I believe it will be not scalable, but it probably depends on the scale. It depends how big is your environment you are managing by the Nephew. But if you would like to have metrics, logs, traces, insights, etc., it may be overwhelming for the management cluster to do that. But we can think of some mechanism maybe later in
the storage may be somewhere else on cloud per se, or on the centralized data centers. But yeah, I mean, that sounds like that's a good input. Subhash?
Yes, Stephen. I also echo the same thoughts from Peter. Because in service assurance, we are trying to create one actor pod. So that would be responsible for taking actions on those NFs. So based on the use case or based on the real-time requirement, we are planning to keep in a workload cluster, either in a management cluster. So how you specified the high-level application is consuming the data lake. So similarly, I suggest we should have some low-level application consuming the data from data lake in the workload cluster. So that arrow, if we can define it here also. Just in order to give a idea, the LF assume that DU is a NF and it is generating the PRB utilization related KPI parameter in the workload cluster. And based on that, I need to take an immediate action by changing the bandwidth. It's like I'll increase the bandwidth so that my PRB utilization goes down. So I would like to consume the same metrics in the workload cluster. The actor pod will consume it, and it will reconfigure the NF.
Yeah, so I said consuming them while it's being emitted by the network function is definitely part of the requirements on a workload cluster.
Yeah.
Storing them for a very long time.
I agree with that.
Would be a bit different. Yeah.
I mean, like real-time data you can keep in the workload cluster, and or any historical data or any it's like a historic data you can keep in the management cluster in some storage. But yeah, real-time data, I think you try to keep somewhere cached in the workload cluster.
Yes. So cool. Right. Yeah, so I have the same view. So because I need it for my operator too, for sure.
Yeah, right. So maybe in this first simple diagram, we could add a low-level application, how it is consuming from the cache. That
add. So there should be a line here. So sorry.
Yeah.
There should be a line here that can go through this, and then this would actually go send the data out to.
Yeah. Okay.
Cool.
Yes. Thank you.
Next one. So one thing that we, again, it's very strong for me to say the community converged on the last meeting, because there's very few of us actually attended the last meeting. But the thing we did sort of agreed on, and very, very, in my opinion, very, very correctly so, is we are not thinking of creating a Nephew specific set of interfaces for instrumentations for backend supports on our stuff. So we will conform to OpenTelemetry, meaning that using OTel. Particularly, what we are asking is, well, ideally the network function vendors would be conforming to OTel. That would be great. So they can use open tracing to emit traces. They can use open sensors for signals. Otherwise, obviously, particularly in the next slides, we talk about 3.5GC doesn't have anything. Period. We would like to, at the very least, build something as a sample that would show to network function vendors that even there are mechanisms where with existing non-OTel oriented network functions, there code that we can build to help them to be more OTel compatible. So it'll be a little easier for us to leverage on some of the backends that are already doing. OTel builds their own collectors and things, and it has the whole receiver, processor, exporter relationships. So that allows us to plug in things that are either specific to 35GC or specific to Nephew on our architecture. So I think if we conform to the interface, we don't have to create our own too much of our own interfaces, and we'll be able to leverage a lot of people who are actually supporting OTel right now. So that would be a very strong inclinations of moving that directions. What does that mean, really? Going back to your first diagram, you just send data and then someone will be able to read the data. There's a lot of questions. There's a lot of things that are missing that are still undecided at this point. One of this is, as we said, 35GC basically has no metrics emitted, and they have logs, which we've been using for debugging, so it's been useful, great. But they have no traces, which is also pretty common. I don't think many network functions emit traces. And then, so the idea would be if we just take 35GC, there's no way for us to actually get anything useful out of it outside of logs. And 35GC is one of the obviously target default implementations, default 5GC implementation anyway, thus far for Nephew, and therefore we should, for R3, I don't see that going away. So R3 at the very least we should try to make it work. And the opportunity here is we may be able to do something such that it would work for something more generic cases. So I think Mas and others was in the last several meetings, and we talked about, hey, let's build a sidecar. The sidecar is built with whatever mechanisms used. It could simply be a sidecar that pulls Linux statuses off of your pod. Sidecar is obviously a containers within your workload pod, and if specifically for 35GC, because your network function only has one pod, each of them only has one pod. That sidecar lives in the same local host. They can talk to each other using the local host. They share the same network namespace. So over there, if you can, there's a variety of Linux tools that you can use that would be looking at the same network namespace, and then that would allow us to get information like, oh, what kind of sessions are there? There's a set of socket connections that are in place, and ifconfig, very simple. It can give you packet counts off of the multiple interface, including secondary interfaces. I think Martin has been working on, at least last time, if you look at our Slack channel, he's been very active in checking that out. And then he's talked about C advisors, I believe last time. So I welcome anything that you can think of that are useful, because there are tons of stuff outside and we don't have to really build our own by default from scratch. There are tons of observability pieces that are able to scrape network informations, at least up to some very standard things that we can expect out of every single network functions that we can support moving forward. And the sidecar, what we expect is also be an OTel SDK to build the outbound interface. Go ahead, Pietro.
Yeah, great. So I think for the R3, it will be really good idea to start easy, so focus on the sidecar. But for the long term, we need to think, in my opinion, about pushing this responsibility more for the eBPF part rather for the sidecar. Again, it's kind of scalability issue, and it's eBPF is less intrusive than using the sidecar, but eBPF cannot do everything. So
yeah, so there were suggestions too, that which I also suggested. So this is a deck that came from last time, if Martin actually remembers. So at that time, BPF being used, there are two ways. One of them is you have a privileged mode daemon set, out of your clusters. So every node has one, and then there's a special privilege given, or you can run BPF off of a host applications. So obviously the sidecar should not be the one taking like privilege mode and able to load BPF programs. But then the idea moving forward, actually, the even when Vim was here last time, we do agree that if we want to have like a Nephew specific helper, if you will, and then it's an optional for network function vendors to leverage them. But then that regular or standard, if you will, well, not standard is a word, was a bad word, or the baseline implementations of getting informations off of your network functions. At the time, we were the one thing that the BPF would be very useful on, particularly, would be on trace, because at the time of the socket establishment, socket connected, or any things when data sends out, we'll be able to detect that off of BPF. So I strongly want BPF to happen, and L3, I'm not sure, of course, but then moving forward, that's absolutely one of the P's that we should actually use inside, and they give us a lot more visibility into the system, and then send it out. So I agree with that. I also not so sure that this is an L3 items, depends on the contributor list. But then for now, one thing that we do want is let's make sure that when you export it, once you get those data, you export it out, it would be an OTel interface. So we'll be able to capture it using a collector.
Yeah, I agree. It's better to start easy. As a reference, the friends of mine from Orange, I mean, he's probably not at Orange anymore, but he was doing PhD, and he had some work on the observability via eBPF. He was creating some protocol-specific, 5G protocol-specific eBPF programs to collect. So it's really useful, and the overhead is really minimal. And he was trying to compare the sidecar version of the observability with the eBPF, and the results were really different. So, but just like you said, for R3, stay as simple as possible. I agree.
Yeah. Well, either you use it as host or daemon set, with purely PPF based observability engine, which also there are tons right now. I think the Cilium folks build their own BPF based observability engine, which is very in depth, I think. And if we leverage any of those, we still want to have an OTel host interface or some sort of daemon set that we're able to get those data and then expose them using OTel. And then if you have that would be awesome. Yeah, go ahead, Marcin.
Just a quick note from my side, because running eBPF will require net admin and sysmodule capabilities, at least, and those come with their own. Let's just say there were consequences with those permissions. And last time that this was voiced, did we come to any conclusion about this being a security issue? Or
yeah, that's right. So our conclusion is obviously not a sidecar. So if you want to use a sidecar that can load a BPF program, that is not acceptable. An application would not be able to get that privileged. But then if you run it as a host program, or like Cilium, if you run it as like a privileged based daemon set, only as an infrastructure piece, basically, I think those two are probably something that is acceptable. We have to communicate that obviously with the user community, but then for sure, as host applications that has a special privilege, I don't, and then have the infrastructure team installing them, I don't think that's like a really big obstacle. Yeah, go ahead, Sebastian.
Yes, Stephen. Are you considering a use case where, let's say, we need only file read from the NF to get those KPI parameter for the observability? So is it possible that we do it outside also, some configuration, and read those parameters from the NF? Maybe some simple REST call or any file.
Yeah. So I think Masen and I talked about that last time too. We, as you know, for our 3, we're not too ambitious. UPF is probably the only the one thing that we're targeting, but for FreeFlyGC. But then for AMF subscriber count is the one that we're looking at. That one we can get out of the blue from networking information. So we need to get it directly from FreeFlyGC, which unfortunately does actually expose API for that particular things. So in that case, you can also create a sidecar that that would have credentials to invoke REST API calls directly to the pod, and then those information you can also expose using OTel. So that's one possibility. Again, I'm not here to tell people how to implement, but then I just want to see these are the areas that may actually have to do. But yeah, it is possible to have sidecar that invokes REST API. In fact, probably you can internally create credentials that they can read. That would be a little easier.
Yeah, actually, Stephen, I'm bringing this too because as a part of service assurance, we would like to go there. So if you help us to achieve in the R3, then we'll able to showcase some good demo. Yeah, as a part of the R3.
Yeah, cool.
Okay, so I believe that that we can do right, and the
sidecar. Yeah, able to sidecar to do a REST API call. Absolutely. I think I've done something even much more elaborate. I've done a sidecar that SSH into the main pod, and then able to apply stuff. So that's all pretty cool.
Thank you.
Go ahead, Kieran.
Yeah, sorry, it's the first time I've been to any of these meetings. So I was just wondering, I guess what I'm seeing here is what we're discussing is observability of the workloads that Nepio deploys. We're not talking about observability of the Nepio use cases themselves or the Nepio components.
Oh, I see. No, we're not. No.
Okay. And
which could be something. That could be something. So I mean,
I think it should be.
Yeah, it should be. I think Bala actually mentioned that last time. That they're at least for debugging. Well, but then actually even Bala's context was talking about, oh, you deploy, but then does it really work? How does it go? Yeah, the components themselves on the management clusters. That's an interesting one. Actually, we're not addressing that directly at this point for sure.
Okay, my expectation coming into this was that we were starting to talk about how you observe what Nepio is doing, but it seems more that we're looking at requirements on the workloads. I mean, is the expectation here that what Nepio provides is a set of requirements that workloads provide open telemetry compliant data formats, or is it that we provide an SDK to support the conversion of existing observability frameworks? I mean, for example, I guess a 3GPP compliant workload might expose O1 PM data, or sorry, 3GPP PM data, FM data, and so on. Is the expectation that the SDK provides conversion mechanisms for that, or what's the end goal?
So we are, yes, absolutely. So that there will be a later slide saying that there's some operator needs, then therefore we may actually integrate that into Nepio SDK. So the exposing of the data for sure, the data that what we're asking for network function vendors to do is that if you want, when you expose your visibility data, we do want to actually have them be OTel compliant data formats. It will be a little easier for us to know how to collect and then have a uniform way to collect them. It's not, and it's hopefully not overly controversial. So that's one side of the equations that we are asking.
Okay.
Not the only
and
thing,
that could and that would be a requirement of the NF. I mean, the observability sidecar here is kind of specific to free 5G core.
Well, so we are not, we are obviously, so as you probably know because you've been attending the SDK meeting, we are also very keen on getting network function vendors on board with the thinnest obstacles possible. So yeah, I mean, if we can, so at the very least we'll be building samples as in how to build the sidecar. If the sidecar that we build are useful in general, or it can be pluggable backends where you can use O1 data, for example, to be exposed in OTel compatible formats, we should explore doing that too. Maybe in the context of SDK, not here in the observability group. I just happen to be in both groups, but then that would, once that becomes a requirement, it could probably, that requirement probably get propagated into the Nefio SDK to make it easier to onboard.
All right, thanks.
So yeah, this is one of the piece. This is one area where we want to create a more baseline set of metrics that we would on visibility data. It's not metrics, not just metrics that we will expose, even as something as simplistic as Prefab GC, and then we'll send it out there. We'll send it out and then we'll collect them. So this is one, I think, for observability team, that's absolutely, this is one of the basic area that we have to tackle. The data is exported. The second idea would be, and I know this part is already being talked about for folks, but I think for sure we need to expose the data and then to be collected on something that sits on the management cluster. So where's this path come from, right? That's the second part of the equations that we haven't addressed. I think Wim actually talked about that several times. I briefly went into the Friday meeting, the RX the release scope meeting last week, and then he did say, you know, that thing is being. He said that Stephen looked at that thing. That's true, but it's not definitive. So some questions, right? So whatever cloud platform we're using, I mean, let's say we're using our kind clusters, that basically means that the container lab network setup needs to at least give us a path to go from the workload kind clusters to the management kind cluster. And that's there anyway. It's just that it's not exposed. The second part would be whoever the receiver is. So OTel actually does have that definitions, by the way, or at its best practice. So an OTel receiver on one end, able to export the data out to the receivers that sits on a different clusters. This is OTel multi-cluster. And in that case, they kind of pun on the credentials and security aspects by saying that, you're going to manage your own keys and things, and then trying to have your own way to export the keys from two sides and share the public keys and things like this. So I think SIG 4, SIG is going to be addressing the best practice of how to do that in terms of credential management, key management, and things. So we don't, observability team doesn't really have to do this. But we do have to at least define, and I think that's extended to the entire SIG too, but at least define how do you expose the IP address of the of your receivers or whoever, the collectors or whatever, something that takes your data sets. That would be the server that sits on management clusters to the workload clusters, because in that case, your management clusters, let's say, creates the OTel best practice. So you create an OTel receiver that is sitting on the management clusters, and there's a receiver that would export data to that other to that management cluster receiver that sits on workload clusters. And by default, they have no idea what that IP address is. We expose that using service and maybe external LB, but then we don't have a DNS server that sits between the two where we can insert the IP address. But even if you have a DNS, which is private to Nefio, you still need to resolve the IP address and be able to communicate the IP address. So the Google seed code that we seeded, which were largely not used, to be honest, did have a way to do this, which is when a cluster is registered in the management cluster, the cluster name and the deployment repo name is the same. So from that, by accessing that deployment repo, we immediately send a package that will contain just one CL. Inside, it will tell you what my public IP is for the service to receive your data. So that's one way that we did it on our side. Many people didn't like a lot of things on this, but at least this I don't think is overly controversial. I'm not saying this is the way to do it, but then that's another area to resolve, which is the knowledge of the collectors that sits on management cluster. How do we communicate that? And whatever we do here, or would probably have implications on how we'll do it in general for all the SIG automations. So hopefully we get something great out of this. I would imagine we are the one with the biggest needs of sending feedback data back to management cluster. So we have to create that feedback path back to management cluster. Right now it's a one-way street. When you the only thing we do is basically just send a well, actually it's just Gig. It's just a Gig repo. So we send in Gig repos, and we're expecting a world cluster to do the right thing. We do actually maintain the credentials. Depends on how you do the backends of creating the workload clusters. Right now, the kube configs for the clusters are actually stored in by the management clusters, which is a bit of a hack. We probably don't want to make that assumptions all the time. So, yeah, go ahead, Pietro.
So I'm not sure if I got all your points, but again, we are back to the scenario when we are using the local data and the workload cluster. I mean, it's easier just to push the data to the management and do not fetch them to the workload. So this division of the responsibility, so that would be really easier in my point of view, that on the workload, you use local data, and if you need something on the management cluster, then you use it on the management cluster, or you expose to the external entities, but you never need to access the data from the workload to the management. Because here I have some problem with that's why you have GitOps and you do not interact with the clusters. And then you would like to introduce some mechanism that you use kubeconfig. It's not maybe entirely right.
True for regular GitOps, that your clusters are very separated and not related, actually, in a way, other than running compute powers. For network functions, however, so I wrote the NF topology controller, as a lot of you guys know. So that spreads across different clusters, workload clusters, and we do sort of have to have an aggregated view of saying that, oh, your 5G core deployment, this is what it looks like at this point, and and even the full service that a user would expect off of the combinations of all the network functions, individual network functions, that they would probably look at that and say, oh, I would like to get a view of the health of my service, and that probably go across clusters. So I do think there is a requirement is a strong word, but there's a need at this point anyway, from what we know, that there has to be a central entity that would collect some data, at least, from all the workload clusters that we know are network related on my service, and maybe you want to get that view where you'll be able to see, oh, this is working, or something's not working because SMF is down or something, or has a downtime of been down for so long, and then suddenly we have a UPF that is not getting more new sessions and things like this. So
yes, I agree. So this one way you definitely need to push the management, but the question is how you use this data, because maybe you will be able to use Nephew mechanisms to orchestrate the observability. Just a buzzword at this moment, but we can see. I have one comment on the topology component. I mean, because I saw that you'd like to store the status data in the topology. The problem I have with that approach is that topology will be not necessary component, right? But if you would like to store the status in the topology, then you have this requirement that if you need an observability, then you need to use the topology controller. And
no. So topology controllers, as I wrote it, was meant to be a sample. So they're basically showing people how do you define topology in Nephew, basically. And then using PBS and then able to use the which isn't really there yet anyway. But then you should be able to use the functions to be able to realize that topology. So right now, topology controller is nothing more than a status of things that are realized, meaning that a new cluster comes up, and therefore I know I'm going to deploy network functions there, and then I know they're connected. They're supposed to be connected. So that's basically just an application, sample applications to use. I would say for simple testing, for observability, it's nice to have a topology controllers to leverage the observability pieces. Observability should not be depending on the NF topology things, because including CLDs is not even standard Nephew CLD per se. We're writing it, although we've made it to API, but API repository, but it's not meant to be, unlike say NF deployment, it's not meant to be something where we expect a lot of folks to conform to. It's more like a sample. Yeah, so topology is one example, I would say, to say, oh, how do we aggregate statuses, and then able to get you a view of the aggregated status of all the individual networks network functions that made up of this topology. So you know the health of the topology that you as a user expected, or service that you as a user expected. But it's not. Yeah, it's not. It doesn't drive observability, or it doesn't drive anything actually, for that matter. It shouldn't be. Go ahead, Martin.
This might be a little bit off topic, but also, if I recall correctly, with the NF topology controller, the status doesn't actually refer to the status of the pods of a network function, but only what was inserted by the Porch controller into the Git repository. So it's not really a status.
No. So yes, up to this point, because there's no observability to send me feedbacks, the only thing you could do is up to the point where your package is approved. Is when I said this is deployed, and then they were updated on the topology by saying that this network function's name, which is basically package name, is now being realized. Because if you look at the CLD for NF topology, it's not a definitive topology. It's more like anything that fits that label of a cluster, it would always deploy these network functions, and then that network functions and corresponding network functions that are connected to them are going through the same fixed network, and therefore once they're created, they are connected, and so that basically where topology controller right now ends, which is anything that gets deployed, we assume it's deployed successful, and then saying that it's being deployed. And the second thing that is needed is to read the NF deployment status, and understanding that, oh yeah, right now the conditions are met, and therefore this is actually running right now in the system, which is still very light level, which would mean the running just means that the pods that are expected, or all the operators have different, or all the network function operators have different way of interpret this. But then for 3.5GC, it's basically just say, oh, the pods comes up and it seems to be functional, and it updates the conditions. And so we haven't been able to read that, and that's the one thing that we should solve, which is we don't have this backup path to send back. Oops. To send something back to management cluster. So imagine this being the NF topology controller. They're one of these high-level applications that needs to say, hey, give me the statuses updates as they get updated by the NF operator, and then I'll be able to update my status to see whether or not it's actually working. So we don't have that path yet. So we had this path on the Google seed code, but there are certain things that only works in Google. Google Cloud, we created a VPN that allows you to have a pod IP address, so they don't have to have any specific IP address. So the IP address exposed doesn't need to be exposed as a public IP on DNS because it goes to a VPN link between the edge cluster and the management cluster. This obviously doesn't even work on Kine now VMs. So that's because of this. This is one of the big obstacles of pushing into, if you probably heard about the ESA component, the edge status aggregator component. So that thing it runs. It's just that it's not working because this part is not resolved yet. And I'm not even advocating using that, by the way. So right now, I think we are past the point of using that piece of code for SIG code. But we do still have to solve this problem, which is how do you expose some sort of collector or receiver or just some sort of ingress node controllers that sits on the management clusters and be able to communicate that information down to whoever is sending that information back out. It could be most likely an OTel receiver in this case. They'll be able to stream this back into the management cluster. So they need to know what that IP address is, the server port numbers and all that stuff, and then be able to send the information back to a management cluster. So we're missing that one path. So I'm just, this slide, it merely points out that we don't have that. Yeah, go ahead, Subhash.
Yes, Stephen. Just out of this topic, just as a general query I would like to ask. Do you think in a data lake, only the workload cluster related stuff gets populated, and within the something we need to observe in the management cluster also, right? So could we update those status also?
So if they expose it to the data lake, so data lake, if you read it up, contains 4 components. One of them is ingesting data. So the data ingesting doesn't mean it has to be an OTel. It's just that there's some way to send the data back in, to send the data, pump the data into the data lake, and then they'll ingest it. So that could include management clusters. It should actually, in fact, include management cluster components.
Okay, perfect. Okay, thank you.
So that's one. And then another area, which is what everyone talked about, and I know that very well. The operator needs to have access to that data, but then that could happen obviously before they got written into collector. The moving forward, what we're hoping that the NF operators will be dealing with really reconciling the intent on more than just A1. So, for example, for UPF, that would be the up and down link throughput, and how do you calculate that, and then how do you decide you're no longer able to service up to that level of throughput? Is obviously implementation operator, but the operator needs to have data to be able to determine whether or not they're not able to satisfy the intent on this case. So we have to figure out a way of obviously once we figure out how to access the management cluster piece, we need to stream the data to management cluster or batch them and send it over. It's all kinds of different modes of send, obviously by OTel, and then store them on management cluster. At the same time, those data that are of interest to the operators, and it is accessible by that NF operators, because obviously we're not looking to have NF operator able to read the other NF's data. It's like someone from vendor A would not be able to read data from vendor B. Not at that level anyway. So we have to access control all of that, but then if they're interested, they should be able to get them. So this is, I mean, some possibility is like you can use the OTel collector and write our own receiver even to be able to do that and send it over to the operator. But then whoever wants to look into that area would have to kind of figure out how do you expose data that get scraped by some local engine. Even that local engine is not determined at this point. But then if your OTel is based in an OTel receiver, and be able to write another exporter at the very least to be able to send it over to either an operators or something that further distributed data to different operators. So that's one area that we have to kind of figure it out. But it is a requirement that there is local controllers, operators, if they have the access right, they should be able to subscribe to some data sets, and then they should be able to get them in real time. Maybe we only do streaming mode and no batch mode, but then we'll see how it goes. Batch mode means that we have to store them, which is, at this point we don't have anything infrastructure pieces to store observability data in the workload cluster. And the next thing would be the data lake, because now we only have 6 minutes left. Let's go a little faster. As we said on the first slide, we need to have something on the management clusters that allows users to be able to just have access to management cluster, and without going to every individual workload clusters to read the data. So on the last meeting, that was suggested that we should just build data lake. That sounds good. So we have the build data lake. Normal data lakes are built with various different things. I mean, the most common things are Spark on top of the Delta IO from Databricks, I think. And then how you ingest is a different story. And then once you have Spark, you can use Spark SQL to access. Even Delta actually put them into more table formats. So again, not saying you should do that, but that's an example. The bad thing is data lake by default doesn't really have some sort of alert system. I think commercial ones does, but I'm not sure the open source one does. So we may have to build something to send an alert, because I think one of the requirements for sure is that if something in aggregates reach a certain threshold, or it doesn't meet a certain threshold, that the high level application may want to subscribe to getting that alert, to understand that something gone wrong, basically, in their definitions, or have to react to it. I think that's may or may not be something we want to do in L3. Depends on SA requirement, actually, more than anything in this case. But alert system would in general be good in even facing users. So we'll see how that goes, because setting up a data lake itself is already some work, obviously. And then you have to have some storage backends, which is also TBD at this point. But then this usually which cloud you're going. But then kind clusters, there's no amazing object storage system that we're using right now. And then the end-to-end tests. So this is, I think, the last one. The last area of things to work on for L3 is user sample replication. So this could be NF topology. It could be, if we integrate with SA, that would be one also. And make it work for FreeFileGC. So the end-to-end is FreeFileGC, at least UPF, to be able to get the data, to be able to also export the data back into the lake, and then the higher level application would be able to read that data, based on, for example, event topology, based on status changes, would be able to just dump all the data within the last 30 seconds or 5 minutes of this particular NF deployment, which is a particular NF instance. That would be awesome. And then that would basically be pretty much our exit, I guess, criteria for L3. If we can build something like this off of L3 and have a more end-to-end test or end-to-end demo to demonstrate that this framework is working, I think this is probably good enough for L3. If SA makes L3, then SA with observability would all be part of L3 pieces. But then, at the very least, when we do integration testing, we do have to build something like this into the system.
Yes, Stephen. So
yeah,
I think with SA perspective, we could try to focus on collecting some KPI parameter on the UPF or maybe ODU, so that I think we can decide and come up together with the user story. So parallelly, we'll be also working on those same aspects.
Okay.
Thank you.
Okay. Cool. Yeah. So this is pretty much this for now, if you ask me, I see that as like a scope. Depends on when I have enough people working on it. That's sort of the scope of R3. So it sets up the basic framework. It will have something that a high-level analytic engines that sits on top of management clusters or in management cluster would be able to get the data and then do whatever analyses that they have to do. And be able to get the data off of a network functions, off of the operator be able to access it, and high-level application will be able to access it. I think those are probably some of the preliminary goals. We can descope or scope larger, which is the latter one being highly unlikely anyway, as we go. But then that would pretty much be what I kind of view as a good R3 goal. It doesn't need to be all three of the operator-based network functions that we have today. As Subhash said, maybe UPF itself will be good enough. And UPF is actually a little easier to define in terms of data. I think it will be more application specific if you do SMF and AMF. And then maybe we'll be hit by 3.5GC when that happens. But yeah, go ahead, Pietro. Sorry.
Okay, thank you. I think this slide is good, and I know we are almost out of the time, but I have one question to start the discussion. Do you know the MCO project, which was before the Nephew? Are you familiarized with MCO?
I heard about it. I'm not familiar. I know it's from Intel.
Okay. I just want to. In the MCO, you had a concept of the logical cloud. So MCO, maybe in some dummy way, but it was aware about all the clusters. Do you believe the Nephew need some kind of the logical cloud to be more aware about all the clusters of the application which are on the clusters and the connections you needed? I mean, because I can, who knows, maybe you will have traces between different clusters, etc. Do you believe this concept may be needed in
I
the
think
Nephew, or is not the case?
We definitely need to know the connectivities between different clusters are intact. We have to know on levels of when not service to service, infra to infra, whether or not they are connected. So obviously, as we talked about earlier, for network functions deployments, the individual clusters, the connectivities between them are an important things, and then we see that as a single point of view to say whether or not our service is healthy. So we need something in that vicinity. I don't know the details of the logical cloud or something. That would be is it too much or is it not enough? So I don't know, but then at least I know we need to know if two clusters are connected in topology. Not saying that I have topology definitions, but at least we know that if one runs an SMF, the other runs an UPF, they need to be connected. We have to get enough information between them to be able to say debug and see whether they're healthy. Or even not just connectivity issues, but then issues on is that enough? Do we have like intermittent packet loss and all that stuff and latency issues and things? So I would, because we're network functions that we're much more network sensitive. So that informations are needed for sure.
Yeah, good to hear that. I also believe it's at some point, not R3, but maybe it should be considered to create such concept. I don't say it need to be named a logical cloud. Just want to refer anything, but this awareness of the topology is probably crucial.
Yeah. Cool. Well, we're at time. So if the folks wants to contribute, one thing would be we can talk about what the areas that you would. I know Martin's already looking at some of the things on scrapping data off of a container and off a workload. So that would be great if you really want to continue doing that. And then generally I see each of this as like an area The end-to-end test is obviously the last thing to do, so we don't have to worry about that yet. But then all the areas of data lake, all the areas of how operators can access data, all the area of what Martin's been doing in terms of getting data off of prefied GCs, those are probably some of the, we can look into those, or if we have enough people, each of us can look into this, and then we'll see what's realistic to do. That may probably be a good next step. Does it sound good? Or if it is, then I probably write up some doc to be shared with you guys, and then we can kind of see what the ideas are, and then what the scope is.
At this point, we from Orange, myself, Marcin, and Ivona, we are at this point interested in the observability in the Nephew, so we probably will try to dig into it, and we need to stay updated and try to meet more regularly. I don't know if every week, but
yeah. So we can
at least
we can do that. We can make a weekly cadence of this. Probably not today, not Sunday, which is Sunday night for me. But not every week Sunday night. Yeah, but then I mean we'll probably around this time though. This time actually probably works out well. I don't see anyone from the amazingly our project doesn't really have that many US people for one. And then I don't see them actually joining for now. So I think we can keep this time, because it's very hard to get like the morning meetings slot. So we can do that. And then I can write up something first as a skeleton of moving forward. Not a design doc, so forget that. I don't want to dictate how this is implemented. But then in terms of area to investigate, so we get a little more information as we go. And then we can meet, as you said, meeting weekly now. So because our development cycle officially started, but our 2 hasn't been shipped yet. Actually, supposedly shipped today, Monday Pacific time. But then since none of us has, I don't think any of us anyway, has very strong L2 responsibility at this point, I think we can start going after L3. So yeah, so let's make this into a regular meeting. Cool. If it sounds good, then we can decide a time, date of the week on Slack, and then we can go from there. Go ahead, Martin.
Yeah, just as a note, are these slides available on the Nephew's Google Drive or?
No, I haven't shared it yet, but I'll share right after this.
Nice, thanks.
Yeah. Cool. So great. So I'll talk to you guys on Slack, and then we'll meet again next week, I guess.
Yeah.
Thank you.
Thank you.
Thanks.
Mhm.
Bye.
Thanks.
thank you very much. Have a good day.
Thank you.
and
Bye.
night.
Yeah.
Bye bye.